So you should have a document called Simulation States of Matter. Before you go to this simulation, you're supposed to predict. So go ahead and type in, how might the particles look in a solid, liquid, and gas? We can't see the particles of matter, they're too small. But if you could, how might they look? And you just want to describe in your own words how they might look. This simulation will allow us to provide a model. We can't see them, but provide a model which will help us to understand how they might look if we could see them. Okay, so we go to the simulation and you do click on states here. Then we can click water is the first one you need. Here's water and solid. All right, so you're supposed to describe, if you want to screenshot it, great, put it into the document. And if you want to do that, that's fine. If you just want to describe what it looks like, that's fine as well. You can do either or both, but either or is what I'll look for. Now we can add heat. So if I click here on the slider, I can add heat, and you can see that's going to change the way the particles move. And so there I went from a solid to a liquid. The solid, if I cool it down, it goes back to the solid. You can see they spread out. In water, they spread out a little more. You might know water, when it freezes, it expands. And when I heat it, I'm going to melt it, and the particles get closer together and move a little quicker. There's a liquid. All right, so up here, this is temperature. This is the Kelvin scale. I went through the melting, we call it the melting point or the freezing point. That's the temperature at which melting and freezing happens. I can go cool it down and freeze it again, make it a solid. I can heat it up, and there I can melt it again. This is what the particles would do if I go, now they're a liquid. All right, so you want to keep going through that. If you want to look up the actual freezing or melting point of water in Kelvin, you can look that up on the, it's 100 degrees Celsius, but that's different in Kelvin. Of course, the Kelvin scale doesn't have any negatives. It starts at absolute zero. So that's why we call it absolute temperature. And that's what this simulation uses. All right, we can also click up here if you want to see there's liquid, solid, gas. If I check this out, I can see all three states of water. All right. Then it's going to ask you to, so keep going through this. It'll ask you to screenshot and or describe. And then the last thing, when you get to the bottom here, you want to choose a different substance. You can choose neon, argon, or oxygen. And you can see the different substances, and you can choose solid, liquid, or gas as well. And if you want to look for the melting point, so neon, I want to go see what, if I chose neon, here's the solid, and here's the liquid. If I want to see what the melting point is, I'm going to add heat until I see those particles start to move from a solid to a liquid. And by continuing, if I want to freeze them again, I can cool it down and see it. So you can look up the actual melting and freezing point of neon if you want. Google will have the information there. But this simulation allows you to sort of get an idea of what's happening during these temperatures. All right. So just complete the document and submit it. And of course, freezing and melting point are both physical properties. And our reading talked about it.